Assalamu alaikum wa rahmatullah. This is the second part of the lecture on Wheatstone bridge. So till now we have discussed the basic structure of a Wheatstone bridge and when the Wheatstone bridge is said to be in a balanced condition. Now let's try to understand one more thing. So, for example, this is R1, R2, R3, R4, this one is R5. Now, whenever this bridge is in balanced condition, the current through this I5 resistor R5, I am designating it with I5. The value of the I5 will be 0, and whenever it is 0, the potential at this point will be same as potential at this point. Now point number 1, if I5 equals to 0, we concluded R1 R4 equals to R2 R3. And second, if R1 R4 equals to R2 R3, it implies that I5 equals to 0. So these are two simple conclusions. Now today we are going to discuss a couple of problems on this concept. First of all, let's start with this potential. This potential and this potential, they need to be equal if the current through R5 is 0. And if this amount of current is 0, these two potentials are same. It means this R1 and R3 are in parallel. This is very important. Now there is a misconception that at times becomes a hurdle for the students. They think that since this current is 0, so there is no role of this R5 in the circuit, or otherwise at times students think that we can just neglect this R5 by deleting this from the circuit like this. No, we have to understand the difference between this circuit and this circuit. They are two different circuits. Anyway, we will practice a couple of questions on this so that we understand the importance of this R5. Now the important thing is, whenever this bridge is in a balanced condition, this I5 is equal to 0, this condition is true for the circuit, then at that time this X and X, the potential will be same. Means this R1 and this R3, they are in parallel. So R1 parallel R3 and R2 and R4, they are again parallel. This point is common between these two resistances, and these two potential values are same when I5 is 0. So again so R2 is in parallel with R4. If we are asked to find the net resistance of the circuit, so these two in parallel and these two in parallel, and combined these two results, they are in series. So I would say net resistance of the circuit will be equal to R1 R3 over R1 plus R3 plus R2 R4 over R2 plus R4. So you do not need to remember this equation, but understanding how we got this equation, that's very important. So, and this is only possible when the drop through this R5 is 0, or otherwise the current through this R5 is 0. If there is some drop, and that's only possible when some current flows through this. If that is the case, the potential here and here will not be same, and thus this R1 will not be in parallel with R3. So this is very important. This is the net resistance of this circuit. So let's do a couple of problems. For example, I have a resistor like this, it is 6 ohm. I have a resistor, it is 3 ohm. I have a resistor, it is 4 ohm. And I have a resistor that is 8 ohm. Fine, 6, 3, 8, 4. And I have one more resistor. Maybe it is 80 ohm. And I am connecting one battery over here, 100 volts. What is the value of the current flowing through this 18 ohm? First of all, let's see this kind of a bridge. 6 4 is a 24, 8 3 is a 24. So you would say this is a balanced bridge. And in balanced case, what will be the current through this resistor? I will be equal to 0. But again, this is the wrong answer. Why? We have to recognize a Wheatstone bridge. Here, the bridging resistor, that is 18 ohm right now, this bridging resistor is between these two extremes or these 2 points. And the battery is also attached or connected between the same 2 points. So this is not actually a Wheatstone bridge configuration. It means a Wheatstone bridge configuration is always like the battery is always connected to the 2 nodes and the bridging resistor is connected to the other 2 nodes. This is very important. So this is not a Wheatstone bridge. No. So what is it? It is simply 8-4 series, means 12, 6-3 series, 9, 9, 18 and 12. All these 3 resistances are in parallel. This is a simple parallel circuit. This is not a Wheatstone bridge. So this answer is wrong, and we learned something related to the shape of the Wheatstone bridge. So everyone has to make sure that we understand this, why the current through this 18 ohm is not 0 right now. Let's move on. We can have a question like this. It's 8 ohm, 4 ohm, 2 ohms. This is 4 ohms. And this is again 4 ohms. And we are asked to find the current through this 4 ohm resistor. The first thing we will do, we will redraw it. How? For example, this is V volts, this is 0, 0, this is V, this let's call it X, let's call this point as Y, 0. Fine. So if we redraw this circuit, so we have a resistance 8 ohm between V and Y, then V and X, Y and X, X and 0, and this Y and 0. So we have 5 resistances. So we can redraw it like this. We have a V, we have at the top we can say X, at the bottom Y, and here 0. So between V and Y there is 8 ohm resistor, Y and X 4 ohm, V and X 4 ohm, X and 0 2 ohm, and 0 and Y 4 ohms, and the battery is connected there. So let's see, is this a Wheatstone bridge? We have a configuration 1 2 3 4 5 resistances. You can say connected in this way. Yes, this looks like a Wheatstone bridge. This is a Wheatstone bridge. We have a bridging resistor, this 4 ohm. Now let's see the condition, the balancing condition in this Wheatstone bridge. So 4 into 4 is 16 and 8 into 2 is 16. So this is satisfying the condition. Since this 4 into 4 16 and 8 into 16, since these values you can say are same, or rather I would say this circuit follows the condition that R1 R4 equal to R2 R3, the current through the bridging resistor will be 0. So the current through this will be 0 amperes. So this is a Wheatstone bridge, and that too in a balanced condition. आगे बढ़ते हैं. Let's move on. For example, we have a case like this. Like this, and we are asked to find the current through this 4 ohm resistor. How will you do it? But will this be a Wheatstone bridge? See, this point and this point are at same potential. This is a simple conductor. Since these 2 points are at same potential, these 2 resistances are in parallel. So 12 parallel 6, the answer is 4. The resistance between these 2 points is 4 ohm. Now this 6 and 3 are in parallel. The resistance is 2 ohm. So 2 ohm, here we have how much? 4 ohm. 4 plus 2 is 6, and then we have this resistor connected to this point and connected to this point. How to do this? So this will simply be one resistor, combination of these two, combination of these two, 2 resistor, 3, 4 and 5. So I can redraw it, and this will be like This one is the combination of these two, so this is 2. This is the bridging between left and right, so it is 4. This one 2 will stay there. 12 and 6, that is 4 ohm. This will be here, and then we have the 6. Now what will be the value of the current to 4 ohm? Since this is 6 into 2 is 12, 4 into 2 is 8, this is unbalanced Wheatstone bridge. This is unbalanced Wheatstone bridge. This is not balanced. So the current through 4 ohm will not be 0. This will not be 0 amperes. Simply. Is there any chance that we can change a couple of values so that this Wheatstone bridge will be balanced? Yes. We have 4 2s are 8, so this is 2. If I replace the 6 with 2, like this. If I replace with 2, so I will have it, sorry, 4 2s are 8, so 2 4s are 4. If I replace it with 4. Now see, 4 2s are 8, 4 2s are 8. This is balanced. In this condition, current through 4 ohm resistor will be 0. So what we did, this was a Wheatstone bridge, except that the resistor over here, this was not a single resistor, rather we were asked, you can say we had 2 resistors and we had to combine them to form this 2 ohm resistor. Likewise we did here, but overall this was a Wheatstone bridge. Let's move on. If we have a question like this, and all these resistors are RR. And if we are asked to find the current through this resistor, now see, we have to find the resistance between A and B. It means we can assume that we are applying some voltage across these two. Now see, this resistor is simply between A and B, but these 5 resistors, 1, 2, 3, 4, 5, they are constituting a Wheatstone bridge. See, so I can redraw it like this. This is AB, directly R. Then we have this circuit. And what is this circuit? There is 1 and 2 resistors. 1, 2 resistors. 1 and 2 resistors, and in between these two we have a resistor R. So in between these two we have a resistor R. Then we again have 2 resistors connecting to the same point. So I have R, and then there is R. See, now this upper part forms a Wheatstone bridge. So here is the Wheatstone bridge, and this R is directly, you can say, between this A and B. Now the current through this R will be, is this balanced? Yes. R into R is R square, R into R is R square. So the current through R will be, this one R will be 0, this R. And if the current through this R is 0, what will be the net resistance of this circuit? So R parallel R, that's R by 2, R parallel R, R by 2, and R by 2 and R by 2, we will add up, that's R, and this R will be in parallel with this R, so net answer will be R by 2. Let's solve one more problem. For example, we have a 8 ohm resistor and 4 ohm resistor, and here we have 6 ohm and this is 3 ohm. So 8 into 3 24, 4 into 6 24. So this will surely be a balanced. So this is any resistor, maybe R, and we are connecting one battery. What will be the current through R? This is balanced condition, so current through R will be 0. Done. Now, a couple of times in JEE, we were asked to find the current through the resistor if we swap the battery with this bridging resistor. So we will go for a swap. This resistor will go here and this battery will go here. So we will get a circuit like this. 8, then we have 4, then there is a battery, then we have a 6, 3, and then we have a resistor like R. See, it's like this. Is this a Wheatstone bridge? The battery is connected. First of all, let's see, are there 5 resistors in, you can say, in a way that resembles a Wheatstone bridge? Yes. 1, 2, 3, 4, and this 5. This is connecting the opposite, you can say, these nodes. So this resembles a Wheatstone bridge. And is battery connected to the, you can say, the other 2 nodes? Yes. Battery is connected to these 2 nodes, whereas this bridging resistor is between these 2. So this perfectly, you can say, constitutes a Wheatstone bridge. Is this in a balanced condition? So let's try. 8 into 3 is 24, 4 and 6 is 24. So the current through R will be again 0. Now what we conclude from this question is, if in a balanced condition, the bridging resistor from the this Wheatstone bridge is swapped with the battery connected to these nodes